In this video, we will continue our exploration into L'Hopital's rule, and let's just remind ourselves what L'Hopital's rule tells us. If we want to evaluate a limit, such as the one given here, as x approaches a of the function f over the function g, if the function in the top and in the bottom both individually go to 0, then we can apply L'Hopital's rule, and we can evaluate the equivalent limit where we take the derivative in the top, divide it by the derivative in the bottom. Now it turns out that this is not the only version of L'Hopital's rule, that also if the function in the top is going to either plus or minus infinity, it could be either or, and the function in the bottom is also going to either or, plus or minus infinity, then L'Hopital's rule also tells us that this is equivalent to the limit of the derivative of the top divided by the derivative of the bottom. And we will refer to this as being L'Hopital's an indeterminate form of the type infinity over infinity. Let's look at a few examples. Let's evaluate the limit as x approaches infinity of e to the x over x squared. And it's going to be really important as we evaluate these limits, especially with L'Hopital's rule, to have a good visual intuition as to what these graphs look like. So kind of just a quick reminder, x squared looks something like this. So it's a quadratic with a vertex here at 0, 0, opening upward. And similarly, e to the x looks something like this, the natural exponential function. So from the graphical exploration, as x goes to infinity, e to the x goes to infinity, and x squared goes to infinity. So we have one of the indeterminate forms, in this case of type infinity over infinity, which means we can apply L'Hopital's rule. And L'Hopital's rule once again tells us that we get an equivalent limit if we take the derivative in the top, divide it by the derivative in the bottom. Then we start over. As x goes to infinity, once again, e to the x goes to infinity, and so does 2x. So for a second time, we have an indeterminate form of type infinity over infinity. So we apply L'Hopital's rule again. This becomes the limit as x approaches infinity of e to the x over 2. The derivative of the top over the derivative of the bottom. Now as x goes to infinity, e to the x goes to infinity, 2 goes to 2, so the value of this limit is simply going to be infinity. And one more example involving L'Hopital's rule and this indeterminate form. As x goes to infinity, x squared goes to infinity, 2 to the x goes to infinity. So we can apply L'Hopital's rule. And L'Hopital's rule tells us this will be the limit as x approaches infinity. We take the derivative in the top, 2x, and we divide that by the derivative in the bottom. So natural log 2 to the x. Once again, starting over here, as x goes to infinity, the top 2x goes to infinity, and the exponential 2 to the x still goes to infinity. So we can apply L'Hopital's rule again. So we take the limit as x approaches infinity. We take the derivative in the top, 2, which we are happy to see. This hopefully will indicate that we will not need another application. And then we take the derivative in the bottom. We have the natural log of 2, which is already there, a constant, multiplied by the derivative of 2 to the x. So another natural log 2 to the x. Now as x goes to infinity, a constant goes to that constant, but the 2 to the x in the bottom is still going to infinity. And remember, if you have a number divided by something getting really big, that indicates going to 0. So dividing by a big number gives you back a small number. So keep in mind that when applying L'Hopital's rule, it works for indeterminate forms of the type 0 over 0, and as we've seen here, infinity over infinity. And it is very reasonable that we may have to apply L'Hopital's rule more than once.